So now we are going to discuss the topic called couple of force. So we know couple in the sense whenever two equal and opposite forces acting on any body, it will create a couple. So first let us define couple. So this is the definition of the couple. So two equal forces, they are equal in magnitude but opposite in direction, will create a couple. So let us study this couple with the help of a simple diagram. So let us take an object or a beam, let us say. Let this end point is A, this point is B. So let us say the two forces are acting on body. So one is a downward force at point A and the other is same magnitude force but opposite in direction, means it is like this. Now you can see here at point A this force will be acting downward and at point B there is a same force, means the magnitude is same but it is acting in the opposite direction. Now let the distance between this A and B, means the distance between these two forces is, let us say, D. Now it will create a couple. So what type of couple it will create? See, at end A this beam will move downward and at B it will be moving upward, means this body will be moving like this, means it will create anti-clockwise couple. So we can see in the diagram. So this couple is known as counterclockwise or anti-clockwise couple. Counterclockwise couple. Now let us take the another type of couple, that is clockwise couple. Let us take same object AB and the force at point A, it is upward and at B it is downward. So now we can see it will create a clockwise direction couple, you can see, because it is upward force. So it will create a clockwise couple. So this is known as a clockwise couple. So these are the two types of couple of a given force will exist. Now let us see how to calculate the amount of couple which is acting on a body. Couple is, let us say, C. So we know in this case the two forces are equal in magnitude and they are opposite in direction. So if we want to calculate the amount of couple, the formula is the force acting on object multiplied by its perpendicular distance, means the distance between two forces. Perpendicular distance between two forces. So let us say couple is C. The force applied on object is F and the perpendicular distance is D, which is shown in the diagram. Now what are the units for this couple? We know force unit is Newton, distance unit is meter. So Newton meter is the unit of the couple. So using this relation we can calculate the amount of couple acting on a body. Given problem. At A, C, D, there are 3 perpendicular forces and there are 3 downward vertical forces given and the different distances given. So this is the given problem. So I'll read it. The roof truss shown in figure carries the given loads. The wind loads are perpendicular to the inclined members. You can see in the diagram. These 3 are the perpendicular forces. Determine the resultant of all the forces and the intersection with the AB. Means intersection means it is the distance. At what distance this resultant force is acting, that we have to calculate. So let us solve this problem. First, let us calculate this angle theta with the help of given values. So for that, I will take the triangle AD. Let this point is, let us say, K. So I will take ADK triangle to calculate theta. So this point is A, this is D, this is K. Now we have to calculate this angle theta. So we know this A to K distance, that is 10 plus 10, 20, and this DK distance given as 10 meter. So we can calculate this length AD. So let us take cos theta, sin theta, tan theta. So which one we have to take? Let us see this. So here the adjacent given, opposite given. So to calculate the angle theta, so we have to take tan theta because x and y given. So let us write the tan theta. Tan theta is equal to opposite by adjacent. So that is 10 by 20. So from this we get theta as 26.57 degrees. Now to calculate this AD, so I will take cos theta. Now cos theta equal to 20 divided by AD. So now we know this angle theta. So from this we will be getting this AD distance as 22.36. So this is the AD distance. Now this total AD is 22.36. Now let us calculate the length AC. So for that, let us say this point is L. I will take this as A, C, L. We know this angle is 26.57 degrees and we know the length AL, that is 10 meters. Now we have to calculate this length AC. AC can be written as 10 by cos of 26.57 degrees, because we know cos theta equal to its adjacent is a 10 meter by its hypotenuse AC. So from this, if you write for AC, we will be getting this. So from this, the length AC we are getting as 11.18 meters. So now we know all the distances, so we can calculate the remaining values. So how much is AC? AC is 11.18. Now we know this total AD is 22.36. So this total length is 22.36. Now we know all the angles and we know all the distances. So let us calculate the resultant of all these forces first. So we know the resultant R is equal to sum of all the forces, that is Rx whole square, plus sum of all the forces, that is resultant of all the forces above y-axis whole square under root. So this is the formula we will be using to calculate resultant of all the forces. Now first let us calculate Rx. See, this is the sine theta. So we know this angle is 90 minus theta. But this force is perpendicular to this. So if you want this angle, so this angle will be getting as total 90 minus this one. See, this is 11.18 is meter. So this length I will show you separately. This AC length I will be showing separately, and CD also. This total I will draw with a separate diagram. See, we know this angle is theta, that is 26.57. This point is A, C, D. Now let us draw a vertical line. Now this angle is 90 minus theta, and this angle is total is 90. This total angle is 90. So 90 minus this will get this angle. So this will be 90 minus theta. So in this 90 will cancel. So this angle will be theta. Means if this angle is theta, so the angle of this force with the vertical also we are getting same angle. Now what is the force here? This is 1120. This one is 2240, and here this force is 1120 newtons. Now we know the angle of this force with the vertical, that is theta. Theta is 26.57. So this angle is 26.57 degrees. Now all these three forces are parallel to each other, so their angle will also be same, that is 26.57 degrees, and here also the angle will be 26.57 degrees. So these three are the forces parallel to each other, and these three forces are perpendicular to this number. So this angle given as theta. So the middle angle means this angle. So this angle will be 90 minus theta, and this we are getting as a theta. It is explained here. Now let us write the forces about x-axis. So we can see this 1120. So cos is about vertical, but we want about x, so it will be sine 26.57 degrees. So this is a force, that is component of this force about x-axis. Means about this 1120 Newton force which is acting in this direction. Now the another force, that is 2240, is a plus 2240 sine 26.57 degrees. Then the another force, that is 1120 sine 26.57 degrees. Now the Rx means sum of all the forces about x-axis we are getting as 2003.86 newtons. Now let us calculate Ry. Let's calculate Ry. So that is, it is towards downward direction. So minus 1120 cos 26.57 degrees, this one. Then this is minus 2240 cos 26.57 degrees, and its y component, that is 1120 cos 26.57 degrees, and there are other vertical forces, minus 3000, minus 2000, and minus 1000. So the total value of Ry we are getting as, so minus 10,006.86 newtons. So it is about y, means vertically down. So this is the sum of all the resultant forces about y-axis. Now let us calculate the Ry, means let us write all the forces, that is R equal to under root, so Rx, that is 2003.86 whole square plus minus 10,006.86 whole square under root. So we are getting this resultant force R as 10,205.52 newtons. So this is the total resultant force we are getting. So how much we are getting resultant? Resultant R is equal to 10,205.52 newtons. Now this is the answer for the first one, means you have to calculate the resultant. So this is the answer for the result. Now the second bit we have to calculate its intersection, means we have to calculate at what distance this resultant force is acting. So let us calculate its distance. So for that, so we are taking the Varignon's principle. So to get the intersection, let us say this intersection is x. So let us apply Varignon's theorem. Now I will write all the moments with respect to the point A. Moments about point A. So I will take all the moments with respect to the point A. So let us write the moment equation, that is 3000 into its perpendicular distance up to A is 10. Then the another force 2000 into its perpendicular distance up to A, that is 20. plus 1000 into its distance up to A is 30. So these are the movements because of these vertical forces. Then let's take the moment of this force. So 1120 into its perpendicular distance from A is 0. So moment because of this force will become 0 because we are taking this point as a reference. Now let's take this 2240 moment. So it is plus 2240 into the distance of this force from A. We know that it is 11.1 Then there is a last force, that is 1120 plus 1120 into its distance up to A, that is AD. We already calculated, that is 22.36. Now this is the sum of moments of all the forces. So according to Wagner's principle, the sum of all the moments is equal to the forces about y vertical into its distance x. And in this we know Ry. So Ry is how much it is? This is 10,006.86. So by substituting this Ry value which we are getting here, this is Ry. Substitute Ry, that is 10,006.86 newtons here. So the remaining unknown is x. So we will be getting this x value from this. That x we are getting as a 15 meters. So this is the answer we are getting. So since Ry is equal to minus 10,006.86. So in this equation we have to substitute Ry, then we will get this x distance. So this is the required.